Let's write some code with lists. And let's start with a list, numbers, and let's add some elements inside it. So we have 6 elements here. We have a list called numbers, and I specify the elements inside the list using brackets, and every element is separated by comma. And let's print it out. Print numbers. If we run the code, we can see that here are the numbers, basically the same. It actually looks exactly the same as in code where I wrote it. Let's see how many elements I have in this list. So I can just print out numbers or the length of the numbers, and we can see that there are 6 elements. So the length of the list is 6. And you get a certain value. For example, let's see what's the second element. We start with index 0, so the second element is at position 1 or at index 1. And if we run it, we can see that the second element is 2. Now let's see some slicing also. So I want to see what are the last 3 elements of the list. What I can do, I can use slice here, so numbers, and inside brackets, instead of specifying only one index, I can use 2 indices separated by colon. In this case, we will take a slice, and slice is basically a sub list with a starting point and the ending point. The start index is included and the end index is not included. So if I start from 1, I will start from here. Let's write indices here. So I start from 1, so the 1 itself is included. So basically I start from here, but the 5, the end index is not included. So basically I will run up to 4 included. So basically I get 4 elements starting from the second element, and I end before the position pointed with the second value here. So basically I should get, let's see what I get. I get elements starting from 2, and the 5 is the last element here. So basically I don't take the element at position 5. What I can also do, I can, for example, to take 3 last elements, I can write it as so that I start from 3 and up to end. I can write 6 here. So I get 4, 5, and 6. I don't have to write 6. I can omit the end index if I want to run to the end of the list. So I can just have colon here. I have to have the colon because otherwise I would just get element at position 3. But here I take the slice starting from 3 and running up to the end of the list. So I get the same result. Now the problem is that if I don't know how many elements I have to write it so that I take the length of the numbers minus 3 and up to the end. So I get the same result. But in Python, luckily we can use negative indices, and minus 3 means that I start from the third last element. So, and here I also take 3 last elements, and in this case I don't have to use the length of the numbers and so on, so it's more convenient. And I can use the same, for example, to just get the last element of the list, I can just use -1 here. So I don't have to use length of the numbers -1. One convenient thing about slicing is that I can use, for example, starting from 4 and up to 10. I won't get an error if I use indices outside of the list, even if I do it something like that. I don't have any elements besides index 5, so I certainly don't have 8 or 10. But what happens is that I don't get an error, I just get an empty list. Now what we have to remember is that the variable points to the value in memory. And for lists, what happens is that if I do another list, which is basically same as the numbers, I can have a feeling that I have a copy of my numbers, but actually I don't. So if I change numbers so that I just change the first element to 100 and print out another list, what happens is that I end up modifying the both lists. Actually, I don't even have two lists. I only have one list, but two variables, both another list and number, both point to the same list in memory. So, for example, if I have a house at a certain position I have an address for this house, and let's say the house is on the corner of two streets. So basically, there are two possible ways to get to my house. I can point to using those two different addresses. And it doesn't matter whether I use one or the second address to point to my house. If I paint my house to red, for example, it is red for both addresses. So it doesn't matter. What matters is that the actual list in memory or actual house in this position, what happens to that house or what happens to that list. So it doesn't matter whether I get to this list by one variable or another variable. What happens is that it changes the values for both pointers, basically. So here what happens is that if I changed the number 0, what actually does is it points to the memory and it takes the first element inside the memory, but another list also points to the same memory. And if I read from that memory, the first element is modified in this memory. Now let's see a different example. Let's write a two-dimensional list. Let's say it's a matrix. And inside matrix I have one list and I have a second list. Now what I can do, I can print out the first element. First element of this list is list itself. And this is the first list here. So this is the first element and this is the second element. To get the, for example, last value of the first element or the 3 here, I can apply I can consider this matrix 0 as list, and then I can apply whatever I want to do with this list. In this case, I would just want to have the element at position 2, which is the last element. Or I could just write also -1 here. It makes no difference. But let's see if in certain cases we would like to have a copy of a list. Let's start with this numbers list. One easy way to make a copy is to use slice. And to use slice we can say, let's say another list and assign a copy of these numbers. Taking a slice creates a copy, and here I take a slice of the whole list basically. Now what happens is that the slice taken from the numbers is copied somewhere in the memory, another place. So basically now numbers and another list point to the different places. And now if I change numbers point at position 0 to 10, in this case the numbers was already changed, so the first element of the numbers was 100. But let's just remove this code here to make it easier to understand. So basically here we take a copy, make a copy, we will change the first element of numbers, and let's print out another list. Print another list. Let's print also the numbers. So those are the lists here. As you can see, the another list keeps the original values, which just add consecutive numbers starting from 1, but the numbers what I changed, the modification only applies for this another list. Let's try to do the same with this matrix. Let's have another matrix and let's try to do a copy. And what we would like to do, we would like to change, let's change matrix first element of the first element into 100 again. And let's print out another matrix and let's print out matrix. What happens here is the both variables, matrix and another matrix, both have this modification. Why is that? The problem is that we did have a copy with this slice, but we copied those lists, but those lists themselves weren't copied. So what happens is that although I have another list in memory, so let's we can have it like that. There's a matrix which was 1, 2, 3 and 4, 5, 6. And now let's say it's A, like another matrix, and we did a copy. What happens is that the list itself points to a new list, but the first element basically points to this place and the second element points to this place. Or we can actually make it even more precise in a matter of or how it's presented in memory. We can say that we have a list 1, 2, 3, and we have somewhere here we have 4, 5, and 6. And now we have a matrix where the first element is basically a pointer to this, and the second element is pointer to that. I could have more lists here, but that's enough. Now if I create a copy, what happens is that actually it would even make sense to have the M pointing here. Now if I create another variable A, which makes a copy, then what happens is, for example, this copy can be here, but the elements inside here are copied here, but as basically it's we can say it's a pointer or it's an address, memory address. Let's say it's 7 and it's 11. So basically this 7 and 11 are copied here, but they point to the same places. So basically this points here and this one points here. So if I modify this, I will take, or we start from M, we take the first element of M. So basically we take this 7 and then we go, we take the last element, or this one, the first element. So we take the first element of this and change it to 100. And as you can see, as A points to the same matrix or same list, they both have the same 100 as the first value. To actually get a copy of the inner lists also, we can use different functions, or we can actually manually make a copy of every inner list also, and so on. So there are basically different ways to do that. We can, for example, one way would be to have, we can import copy, and inside copy we have this function, another matrix 2 is a copy and deep copy of matrix. And now if I change matrix first value to, let's say, -100 and print out another matrix 2, let's print the matrix also, matrix. Here we can see that now I modified the matrix value or the value inside the matrix, but now the another matrix due didn't have this modification because deep copy basically copies also those elements. So we will have this, let's say it's 1 and 4, 5, 6, and now this A would point to the, then we will have something like that. So the A or A2 points to this list, and inside this list we will have copies of the original lists. And now if I modify this or this, then those are separate values or separate lists inside the memory, and one doesn't affect the other.